Okay, chapter 8, section 8.2, testing a claim about a proportion. So in this section, we test claim about a proportion. You need to know every single thing you learn in section 8.1. So we're going to use population proportion to test a claim, and there are two different type of method. We might use p-value method or critical value method. So we're going to use one of them to test the claim, and we're going to use normal approximation to the given data to test the claim here. There are different methods, but we're just going to focus on normal approximation method. So these are the notation for testing a claim about the population proportion. N stands for sample size, P stands for population proportion, P hat sample proportion, and Q is 1 minus P. Before we do, before we test a claim using about the population proportion, first of all, if it's not given that the distribution is normal, then we need to check these requirements. The first one, the sample observation should be simple random, and then condition for binomial distribution should be satisfied. That means fixed number of trials are independent, and then only you have two categories, success or failure, and then probability of success should be remain same for every single trial. And then the third condition is n times p supposed to be greater than or equal to 5, n times q supposed to be greater or equal to 5, and this is the formula for mean, and this is the formula for standard deviation. Okay, after that we can find test statistics for this testing a claim about the population proportion by using this formula, but I'm going to show you how to use StatCrunch, which will help you find all these values. Keep in mind there are two different methods, p-values method and critical value methods, and which we discuss in section 8.1 as well. These are the three different cases you have to keep in mind for finding the test statistics. Proportion, that is the this is the section for the proportion. So this is a formula for test statistics, and in next section 8.3, we focus on mean by finding the t-score or the g-score, but in this section it's a proportion. So after finding the p-value, we compare the p-value with the alpha given significance level, and then we make our decision. We reject the null hypothesis or fail to reject the null hypothesis. Similarly, if it's a critical value method, then you have to check either test statistics is in the critical region, then reject the null hypothesis. If it's outside the critical region, then fail to reject the null hypothesis. And this is the chart we're going to use to make our final conclusion. Okay, so I'm going to use this last three slides from here to make a conclusion or to solve the problem, and then StatCrunch. So let's look at some examples from homework here. Question number 1, use the result from a survey of a simple random sample of 1075. It's already given that it's a simple random sample. Among 1075 responded, 58% rated themselves as above average driver. We want to test the claim that 11 out of 20, so keep in mind 11 out of 20 means if you try to find the proportion, it's a 55% of the adult rate themselves as above average driver. So here, if you check all these requirements, you will see that this situation satisfies all these requirements. So I'm not going to check it because it's already satisfied. So now identify the actual number of respondents who rated themselves as above average driver. So out of 1075, 58% rated above average drivers. So what is that? Out of 1075 times 58%, that means it's a 623.5. Round to the nearest whole number, it's a 624. Okay, and now identify the sample proportion. The sample proportion is 11 out of 20, which is we denote that by Sample proportion, use the symbol that represents it. What is the sample proportion? Sample proportion is 11 out of 20, which is 0.55. I already calculated that. 11 out of 20, it's a 0.55. Okay, what did I do wrong? 11 out of 20, sorry, it's a 58. Sorry, no, that's not sample proportion, that's a population proportion we're trying to check. So keep in mind, the sample proportion comes from the sample data we collected, so my bad, it's 58%. So always keep in mind the difference between the sample proportion coming from the sample data, and then the population proportion we are trying to test is coming from the claim. For the hypothesis test, identify the value used for the population proportion. This is the population proportion. So P is 0.55. That was the mistake I did. That's the population proportion we are trying to test. Okay, let's look at this problem. A certain drug is used to treat asthma. In a clinical trial of a drug, 16 of 254 treated subjects experienced headache. The accompanying calculated display shows the result from test of the claim that less than 10% of treated subjects experience headache. Use the normal distribution as an approximation to binomial distribution and assume 0.01 significance level to complete part A through E. Okay, so this is the value coming from the calculator. First of all, I'm going to show you how you can find this value. If you go to the StatCrunch, go to the stat and go to the proportion stat, one sample with summary, and put the value here, 16 out of 254, and then hypothesis test is the claim is less than 10%, so the hypothesis test would be the null hypothesis would be 10%, so 0.1, and alternating is less than 0.1. And if you just fill out this information and hit compute, these are the information it's given here. Look at here, G-stat negative 1.96, that's a G-score. That's the value given here. P-value, it's a 0.0246, that's the P-value given here. And this is the sample proportion, 0.06, this is the sample proportion. So this question summarizes everything from this calculator. Okay, so now let's answer this question. Is this a two-tail test? Because we are trying to check less than, so that means it's a left-sided test. And then the G-score here, as you can see here, it's negative 1.97 if you round it to the 2 decimal place. And then P-value, it's given that 0.0246 if you round it to the 4 decimal place. It's from the calculator, okay, it's already given. So what is the null hypothesis? It's equal, so null hypothesis is proportion should be equal to the 10%. And now, after finding all this information, it's a p-value test, so we go here and check the relation between p-value and alpha. If you look at here, the alpha is 1% and p-value we found is greater than 1%. So whenever p-value is greater than alpha, fail to reject. Fail to reject is our conclusion. And since to make the final conclusion, look at here, the claim is not equal, so you go to the left side and then fail to reject. So this is our final conclusion. There is not sufficient evidence to support the claim. So fail to reject, and there is no sufficient evidence for that. Fail to reject the null hypothesis because p-value is greater than alpha, and there is not sufficient evidence to support the claim that less than 10% of treated subject experience headache. That's the final conclusion. There is not sufficient evidence to support the claim that less than 10%. This is a claim. So you just copy the claim from here. Okay. So there is not sufficient evidence to support the claim. Let's go to the next question. A television show conducted an experiment to study what happens when buttered toast is dropped on the floor. When 48 butter slices of toast were dropped, 31 of them landed with the butter side up and 17 landed with the butter side down. Use 1% significance level to test the claim that toast will land with the butter side down. So keep in mind, here we are trying to test the claim for the downside. So one more time, test the claim that toast will land with the butter side down 50% of the time. So the claim is the proportion is supposed to be 50%, and then alternating is not 50%. Okay, so that's the first thing. Well done. What is the test statistics? To solve this type of problem, you can just go to the StatCrunch and fill out the information as I did in previous problem. Go to the stat, proportion stat, one sample with summary, and look at here. Out of 48 butter slice, we want to check for butter side down. So 31 of them landed with the butter side up. So how many of them landed down? It's 17. 17, that's the success for our test, because we want to check how many of them were down. So if you fill out this information and if you try to find out if you want to do the hybrid test for 50%, so use the p-value method, use the normal distribution and an approximation to binomial distribution. After that, supposing the intent of experiment was to access the claim that toast will land with the butter side down more than 50%. So this is the second problem. So for now, it's a 50%. So just hit compute, and it's going to give you the information you are looking for. The G stat, which is G score is negative 2.02. Negative 2.02. That's the G score. And the p-value, if you come here, p-value is 0.0433. So 0.043, that's the p-value. Okay, and now because p-value is greater than alpha is 1%. If p-value is greater than alpha, fail to reject. And remember, we wanted to check equality because we wanted to see either that is 50% or not. So you go to the right side. Does the original claim has an equality sign? Yes. And then fail to reject. So this one would be our final conclusion. There is not sufficient evidence to warrant the rejection. This is our final conclusion. So go here. Fail to reject. There is not sufficient evidence to warrant rejection of the claim. Did you understand? From here, because p is p is greater than alpha, fail to reject. If you go to this problem here, p is 0.043 and alpha is 0.01. No, p is greater than alpha, so fail to reject. And original claim is we want to check it's a 50%, so equality is there, so you go to the right side and fail to reject. So this is your final conclusion. So fail to reject the null hypothesis. There is not sufficient evidence to warrant the rejection. So that's how we conclude. Now the second part is we need to change our requirement here. What is that? After that, this is the second problem. Supposing the intent of experiment was to access the claim that toast will land with the butter side down more than 50%. So this time we go to the StatCrunch again and we edit our option. It's not not equal, it's a greater than 50% of the time. So if you do that, our value would change. So if you do greater than 50%, the value of p-value would 0.97. So 0.97 p-value is, that means it's a greater than alpha. So if it's greater than alpha, and then testing claim is no greater than alpha, meaning fail to reject. But to make the final conclusion, you go to the left side, because claim is greater than 50%. Previously, it was equal to 50%. That was the claim we wanted to check. That's why we went to this direction. But now, the claim is greater than 50%. So to make the conclusion, we have to go to this direction and fail to reject. So this would be our final conclusion. There is not sufficient evidence to support the claim. That would be our final conclusion. So the intent of the experiment was to test null hypothesis equal 0.5, and then alternating hypothesis is greater than 50%, and based on the result, there is not sufficient evidence to support the claim. Make sense? So this time, in this flow chart, you have to go to the left side instead of right side. Okay, because this time it's not. Whenever you start the question and you answer this question, does the original claim condition or equality? If there is equality sign, you go to the right side. If there is a greater or less than, you go to the left side. Okay, so that's the question number 4. Let me do next question. A random sample of 819 births included 426 boys. Use 1% significance labels to test the claim that 51.1% of newborn babies are boys. So you go to the StatCrunch. One more time. You go to stat, you go to the proportion stat, one sample with the summary, and fill out this information. Our job is to find out what is the claim. The test the claim that 51.1% of the new babies are boys. So having a boy is success. So there are 426 boys. So you have to keep in mind, find out the right success information. If they are asking you about, if the claim is about the girl, then you have to find out how many girls out of 819 birth. But in this case, it's about the boy, and we already have this information, 426 boys. And then null hypothesis is 51.1, and the claim is test the claim that 51.1% of the new babies are boy. So that's the claim. Okay, so compute. If you compute, so null hypothesis is 51.1, and then alternating is not equal. So check the answer. And now the test statistics, if you go to the StatCrunch, this G-score is the test statistics. So if you round it to the 2 decimal place, in this case it's a 0.52. Now what is the p-value? One more time, p-value is 0.6005. So 0.601 if you round it to the 1 decimal place. And since the p-value is greater than alpha, what is the conclusion? P-value is greater than alpha, fail to reject. And keep in mind, for final conclusion, you have to use this flow chart, okay? So fail to reject, and the claim is we need to check, 51.1% of the newborn babies are boys, so equality sign. So what is the original claim? Equal, yes. Fail to reject, yes. So this is our final conclusion. There is not sufficient evidence to warrant the rejection. So fail to reject, and there is not sufficient evidence to warrant the rejection of claim that 51.1% of the newborn babies are boys. Now, what does it mean? If you fail to reject this hypothesis, does it mean that 51.1% supposed to be the babies, supposed to be the boys? No, it doesn't mean that, but it failed to reject the hypothesis. So when you try to select this information, does the result support the belief that 51.1% of the newborn? This is not the case. Rejection of the fail to reject does not mean that support. Okay, the result do not support the belief of the new babies boys because there was sufficient evidence. No, that's not right. The result do not support the belief new babies boy. The result merely show that there is not strong evidence against the red. This is the right statement. So you always have to keep in mind, what does it mean? Fail to reject does not mean support. Okay, so that's the answer. I'm going to do one more question now. Question number 10. When she was 9 years of age, a girl did a science fair experiment in which she tested professional touch therapists to see if they could sense her energy field. She flipped a coin to select either her right hand or left hand, and then she asked the therapist to identify the selected hand by placing their hand just under her hand without seeing it and without touching it. Among 275 trials, the touch therapists were correct 120 times. Use 0.05 significance level to test the claim that touch therapists use a method equivalent to random guess. Okay, so the claim is the touch therapist will be right 50% of the time. That's the random guess. So the claim is this is equal to 0.5, proportion is equal to 0.5, and then alternate is not 0.5. So that's the null and alternate hypothesis. To find all other information, you can use stat crunch. One more time, go to the stat, go to the proportion stat and fill out the information with the summary. Okay, out of 275 touch, 120 times the touch therapist was right. And then this is the hypothesis test, 50% and not 50%, and if you hit compute, you find the G stat, which is negative 2.11, negative 2.11. Okay, you find the p-value that is already given here, which is 0.0348, 0.0348, so that means 0.035. And now compare the p-value with the alpha, which is 5%, and p-value is less than alpha. So p-value is less than alpha, so reject the null hypothesis. Reject the null hypothesis. Originally, we wanted to check equal to 50%, so you go to the right side. Equal means go to the right side. Reject. So this is our final conclusion. There is sufficient evidence to warrant the rejection. So reject the null hypothesis. There is sufficient evidence to warrant the rejection of the claim that touch therapists use a method to equivalent to random guess. The result suggests that touch therapists do not suggest that the touch therapists are effective. Okay.